In this course, we're going to discuss and then build the hands for our game, which will be how we interact with everything around us in VR. Hand presence is how we bring more reality to the user and then immerse them more deeply in the experience. We are not just watching an experience unfold, but actively engaging with it. Unlike with conventional video games where we interact only using a controller with a few buttons, we now also have physical presence with virtual hands that align with the location of our hands in real world. We can push, pull, press, turn, pick up, drop, throw objects, all using our own hands in VR. Although there are several ways to set up hands for VR, the core components remain the same. The primary component that we'll utilize will inherit from Unreal Engine's motion controller component. In this project, we're going to be creating a dart throwing game that will require us to enter a game level, walk up to a surface that will spawn a dart for us to pick up, and then throw the dart at a target that will give us points based on if we hit a bonus spot or not. Before we get started on building the dart game, let's take some time to learn how Unreal Engine's VR template handles hand presence and uses it to immerse players into the engine. Navigate to and open our motion controller pawn darts. In a previous video, we discussed how the BP motion controller, which is what our touch controllers are using to interact with the world, is spawned and attached to our pawn. If we look at the spawn actor BP motion controller node that we're using to spawn the controllers in, you could see that there is an additional option in the spawn actor node. The node is asking us which hand we want the motion controller that we are spawning to represent. This is our way of creating one object that we can use for two instances, our left and our right hand. Creating reusable logic like this will not only save a ton of time, it will make your project simpler to use as a developer and much easier to grow or revise. A quick note about how to add these custom objects to the spawn actor nodes. Open our BP motion controller and add a Boolean variable named holding dart. Set expose on spawn to true and compile. We've been given a warning by the engine that says for expose on spawn to work, the variable must be instance editable. So set this to be instance editable. And I'm just going to place this in the category hand animations. Compile again. Reopen our motion controller pawn darts. Notice that we can now set the value of holding dart to true if we want. This can be done with as many variables as needed of any type. The hand variable, for example, is an enumeration. If you are not seeing the holding dart variable show up on the spawn actor node, you can simply right-click the node and click on refresh nodes, and this will allow it to refresh, thus showing the variable. We will need this Boolean in BP motion controller, but it does not need to be exposed. Turn that and instance editable back off. And compile. If you look in our Variables tab, hand is instance editable and exposed on spawn. BP Motion Controller uses the value of this as it is being constructed as well as throughout its life. Open the construction script in BP Motion Controller. The logic here will run during the construction of the blueprints to an extent that any logic placed in the construction script can be seen in Editor while you are designing a new blueprint. Here, it is being used to tell the motion controller component that is reading our Oculus touch data which motion source it should be reading from. Back in the event graph, follow the begin play logic and you'll see that it is also quickly used to scale the skeletal hand mesh so it matches the hand it's representing. Let's make a quick change to the setup room scale outline function immediately following event begin play. The template provides us a way to visualize our play area when we're teleporting. It's currently using the Steam VR Chaperone component to do this, but we will use Oculus Guardian to help us. Delete the Get Bounds and Steam VR Chaperone from the function and the blueprint. Right-click and search for Guardian. Select Is Guardian Configured and connect it to a branch. Connect True to the minimum area rectangle. Then search for Get Guardian Points and change the setting to play area. Connect the return value vector array into inverts and compile. Let's see how this looks in action. When we cast our teleporter out with the controller, it has a rectangle now telling us what our play area looks like and where we will be in it when we teleport. So let's break down how this mechanic works. Keep in mind there are many ways to make this mechanic, so feel free to experiment and use other methods, but for the sake of this course, we will be utilizing it this way. From the event tick, after then to, the arc is cleared every frame on both hands. It then asks if is teleporter active true. It is only active if the user is holding the button to teleport. We know that because in motion controller pawn dart, after pressing the A or X button or clicking the thumbstick, we tell BP motion controller to activate the teleporter and then deactivate the other hand's teleporter. This prevents using both hands to teleport at the same time. Our BP motion controller then runs a function that, if successful, provides us with an array of points to build the arc with. It gets these points from the predict projectile path by object type node. This is commonly used to, as its name suggests, predict a projectile's path. Think of throwing a ball. If you wanted to know where it landed based on its starting point and the launch velocity, this is how you would find out. What is special about this prediction is that it will only succeed if the point you are trying to teleport to is in a location with a navigation system. If not, we can't teleport. If we remove this, we will have no restrictions of where we could teleport to, which might be a cool mechanic in its own right, but can also break the experience. If successful, it sets the blue components that make up the arc we are used to seeing to visible, finds the valid location to place us, and shows us this location by moving the teleport cylinder and all its child components to that location. You'll also notice it rumbles the controller for further confirmation. Inside of the update arc spline function, it updates the arc spline component to follow the path prediction. Finally, it creates a new spline mesh component to follow this updated spline through the whole arc and saves them to an array for immediate deletion. All of this happens every frame we want to teleport, and it all happens seamlessly. Then, once you let go of the teleport button, you'll find yourself in the new location that you designated. The setup of BP Motion Controller provides a flexible format that can be extended easily. If we want to render controllers in the hands to show controls to users, such as in a tutorial, we can replace the hand meshes with controller meshes, or attach the controller meshes to the hand meshes to render both at once. In other words, this format gives us the flexibility to add or change colliders for various interaction needs without needing to change the underlying motion controller component. In the next video, we'll dive deeper into the BP motion controller to learn how it handles communication with the player and the world.